information of circuit interrupting devices. So in power system, current flows at different voltage levels and the circuit has to be switched on and off as per the requirement. Spark is produced when circuit with low value of current is open. Switch is used to switch on and switch off. In our houses, large current flows when a short circuit takes place. In this case, the circuit is opened by making use of fuse. But when the large value of current is to be interrupted, heavy arc is produced, it becomes necessary to quench the arc. This is achieved by using the circuit breaker. So, different circuit interrupting devices such as switch, fuse, isolator, circuit breaker, etc. are used as per the requirements. Explain need of circuit interrupting devices. So, circuit interrupting devices are essential components in electrical systems that automatically or manually stop the flow of electric current in a circuit. So, when high current flows through a circuit due to short circuits or overload, it can cause wires to overheat and possibly catch fire. Circuit interrupting devices break the circuit to prevent damage to the equipment and reduce fire hazards. These devices protect people from electric shock by cutting off the current if a fault occurs. Circuit interrupters protect sensitive electronics and machines against power surges or faults. They allow for safe maintenance and repair by isolating sections of the electrical system without shutting down the entire system. Electrical codes and safety regulations require circuit interrupting devices in both residential and industrial installations to ensure safe operations. So these are some points that shows or explains the need of circuit interrupting devices. List various circuit interrupting device along with their symbols. So you can see the symbol of fuse, isolator, circuit breaker and miniature circuit breaker. This type of question may be asked in Viva Voce examination or in case of practical examination or theory examination in a short question. Explain switch and fuse as a circuit interrupting device. So current flows when the source supplies the power to the load. The circuit has to be broken as per the requirement. This device used for breaking the circuit is known as the circuit interrupting devices. When the value of current is not large, switch is used to open or close the circuit in healthy condition. Fuse is used to isolate the load from supply when the load current increases beyond some value or when short circuit occurs. The switch and fuse shown are generally used in domestic, commercial or industrial purposes at distribution level. In the figure you can see the image or the electrical symbol of switch and fuse that are used for the protection purpose in the circuit. Circuit breaker as a circuit interrupting device. So when the fault occurs in power system, the current of a large value has to be broken. The arc is produced between the contacts when the contacts are separated. Hence it is necessary to quench the arc. Also in the healthy condition, the circuit has to be made on and off as per the requirement. Circuit breakers are used in substation and can be operated during faulty and healthy conditions as well. Circuit breakers are operated during fault. The load is connected and it has to break the large amount of current. Hence, it is an on-load operating device. The electrical symbol of circuit breaker, which is used for drawing one-line diagram or any other circuit operations, this symbol is used. So, it is the symbol of circuit breaker. So, this is how a circuit breaker works as a circuit interrupting device. Explain isolator as a circuit interrupting device. So, circuit breakers are used in substation. When repairing or maintenance has to be carried out on the circuit breaker, it is not just enough to open circuit breaker, but it has to be isolated from the supply side and from the load side. For this, isolator has to be used. Isolator is the air brake type switch which is kept on the two sides of the circuit breaker, or you can say either side of the circuit breaker. After opening the circuit breaker, the isolators are opened, so the circuit breaker is isolated from the two sides. One important point in the operation of isolator is that it should not be open when the circuit breaker is in closed condition, because if this is done, arc is produced across the contacts of the isolator, which results in the fire. As isolator is not an on-load switch, so isolator is not directly opened when the circuit breaker is still in the operating condition. So this is how isolator is used as a circuit interrupting device. Brief information on isolator. So isolator is an air brake type switch which can be opened or closed on no load condition. Isolator is used in switchyards and substations. Transformer circuit breakers are to be isolated from the supply and load side when repairing or maintenance has to be carried out. For this, first the circuit breaker is opened from the supply side and then isolator is opened. Contacts of the isolator are kept at the height and operated from the ground by the handle on a long stick. In high voltage system, isolator provides a visible break in the circuit, confirming that the system is de-energized. Because if the isolator is open while it is carrying the current that is on load condition, arc is produced across the contacts, which results in fire and the operator also gets hurt. To prevent the wrong operation, there is interlocking between the isolator and the circuit breaker. This ensures that the isolator cannot be opened when the circuit breaker is on, and the circuit breaker cannot be closed until the isolator is closed. So this is how the isolator plays a vital role in power system protection. So this is some basic information regarding isolator. Explain in brief basic construction details of isolator. So an isolator is a mechanical switch with a simple but robust construction designed to disconnect electrical circuits under no load condition. Its construction varies slightly depending on the voltage level and type, that is either single break, double break or pantograph type. But the basic parts are same or common. A strong metallic base frame that holds all the components mounted on insulators and often placed on the ground or a support structure. Insulators are made up of porcelain or polymer material and supports live parts and provide insulation between live part and grounded structure. It can be a post type or rotating insulators depending on the design. Conductive arms that make or break the electrical connection include fixed and moving contacts. They are designed to have high conductivity and corrosion resistance, often made up of silver or copper plated or aluminum. Manual or motorized, pneumatic or spring operated control systems that controls the movement of the contact arms and often located at ground level for manual operation. In some designs, arcing horns provided to safely discharge small capacitive currents and prevent arcing ground during the operation. Normally, 3-pole type isolators are used. Arrangement is made so that the 3 poles operate simultaneously. Also, interlocking is provided so that all the 3 contacts open or break or close simultaneously. So this is the basic constructional detail of an isolator. Explain construction of vertical brake type isolator with a meaningful figure. So a vertical brake isolator opens in a vertical plane with the main blade lifting upward or downward to disconnect from the fixed contacts. You can see in the figure, these are the poles of fixed contacts. These are the poles. This is the moving contact or operating rod insulator. Female contact is kept on the post of porcelain and the male contact is kept on another post of the porcelain. So this post of insulator are made up of porcelain or polymer material. The contacts can be opened or closed with the help of middle post insulator. This is the middle post or operating insulator. Base frame made of galvanized steel or another corrosion resistant material. This is the base frame over which this structure is mounted. Insulator columns are made of porcelain or polymer material. Rotating post insulator supports the moving blade post and moving blade or post is motor operated or manually operated that swings up vertically to disconnect the blade. So this operates and swings this blade. This is the blade operates in vertical motion like this. Stationary contacts where the blade sits. These are the stationary contacts in which the plate is stationed or sits are made up of silver or copper coated material to ensure good conductivity. Arc horns, which are optional, are provided to give or provide the arc path during the switching under abnormal conditions. So this is the constructional detail of a vertical brake type isolator. You can see in the figure as well, both the type of vertical brake type isolator are shown in the figure. You can visualize it for the better understanding, and you have to draw this figure if asked in the examination. Explain working of vertical brake isolator. So a vertical brake isolator is designed to provide a clear, visible brake in an electrical circuit, primarily for maintenance and safety purposes in high voltage substations. It works in an open air environment and does not interrupt load current. It must be operated only when the circuit is de-energized or with a load brake switch or circuit breaker. Initial state, that is in closed position, the moving contact, that blade is in the horizontal position, firmly engaged in the fixed contacts on either side, that allows the current flows freely through the blade, completing the circuit. But during the abnormal condition or at breaker maintenance time, during that breaker maintenance, breaker is operated, that is in open condition, so you can open the isolator. So an operating mechanism, manual or motorized, is activated. This mechanism rotates the central post insulator, which carries the moving blade. As the post rotates, the blade swings upward in a vertical motion that breaks the contact with the fixed contacts. The blade stands vertically, providing a visible air gap, ensures that the circuit is safely isolated. The air gap allows inspection and maintenance personnel to visually confirm the disconnection, because by viewing it, you can easily say that the circuit is de-energized. During closing operation, the operator rotates the post in opposite direction. The blade swings back down and re-engages with the fixed contacts, restoring the circuit continuity. So this is how the vertical brake isolator operates. The advantages of vertical brake type isolator. So there are several advantages of vertical brake type isolator. Some of them are listed here. So first is, it provides a clear visual confirmation of the open circuit due to the vertical movement of the blade. It requires less horizontal space compared to the horizontal brake type, making it suitable for compact substation. Fewer moving contacts or moving parts are there. It makes it easier to maintain and more reliable. The large vertical air gap reduces the risk of accidental flashovers and ensures safe clearance. The switching can be completed quickly, especially when motorized. Vertical movement helps reduce contamination accumulation on contacts, especially in dusty or industrial environments. It can be easily integrated with motorized or SCADA control system for remote operations. So there are several advantages, and you can write these advantages when asked in the examination for the question like advantages of vertical brake type isolator. State the limitations of vertical brake type isolator. So some of the limitations of vertical brake type of isolator we are discussing right now. It needs more vertical space for the operations. That is why it is not suitable or unsuitable for indoor or Low clearance installation. This low clearance means the low height clearances. Since it operates in the open, components are exposed to weather, dust and pollution, which can affect performance over the time. Moving part, especially the rotating insulator and blade, are subject to mechanical wear, requiring regular inspection and maintenance. In manual setups, operating the isolator can be slower and laborsome or labor intensive, especially in emergencies. Improper operation or unnoticed backfeed can lead to dangerous arcing, requiring the arc horns or interlocks. So these are several limitations or disadvantages of vertical brake type isolator. The construction of horizontal brake type isolator with figure. So this construction is of center rotating brake type isolator, or say double brake type isolator, means from the center it opens like this, so it breaks the two contacts on the either side. A strong metal base that supports the whole structure. There are three post insulator made of porcelain or polymer. It is shown in the figure. You can see this. This is the center operated double brake type isolator figure. It operates in the 90-degree horizontally, so it breaks these two contacts. It rotates in this direction and on this side, this direction. These are three pole isolator structure made up of porcelain. A rod of aluminum or copper is kept on the middle post. This is the rod of aluminum or copper to make the contact. Middle post can rotate through 90 degree in horizontal direction. Center portion is hinged. This center portion is hinged. You can see in this figure. Center portion is hinged. And whenever the operation is done, the two other ends move in this horizontal arc like this. Female contacts are on the outer poles. These are the female contacts where this pole can insert. These are mounted on the top of the one or more insulators and remain stationary. These female contacts are remain stationary on this 1 and 3 number pole on this direction. It includes a manual or motor driven mechanism via rod or linkages to the moving arm. When operating, it rotates the blade to open or close the circuit. Arc horns are fitted on the moving and fixed contacts to handle minor arcing during the opening. Interlocking mechanism prevents operation under load unless used in the conjunction with the circuit breaker. So this is how the horizontal brake type isolator operates. So this is the construction detail. So you can visualize all the parts and nomenclatures given for the better understanding. So when operated, this center post moves in this direction. It is shown in the sub-figure here. So this is how the horizontal brake type isolator operates. Working of horizontal brake type isolator. So in normal, that is in closed position. The moving contact, that is blade, is in live contact with the fixed contact. So it is fixed in the contact. Current flows through that switch from one terminal to another terminal via that blade. The isolator is in conducting state, so it is usually kept closed during normal operation if the system is energized. Means if the current is flowing, isolator normally is in closed position so that the current can flow from one end to the another end. Before opening the isolator, the associated circuit breaker is opened first to interrupt the load current, because the isolator cannot open during the on-load condition. So first associated breaker is opened, then the isolator is opened. In the opening operation, the operating mechanism, that is manually or motor operated, is actuated. It rotates the moving blade horizontally like this, swinging it away from the fixed contact. This creates a visible air gap, ensuring complete disconnection. Any minor arc during this due to that residual charges or magnetizing current occurs is handled by the arc horns placed in the isolator. In open position, the moving arm is completely disconnected and maintenance work can now be safely performed. So it ensures the complete disconnection or isolation so the working personnel can easily done the operating duties or maintenance. The closing operation, once the work is completed, the blade is rotated back to reconnect with the fixed contact. The circuit is now ready to be energized again via the circuit breaker, because once the isolator is closed, you have to connect the circuit breaker associated with that isolator is closed now and the current can flow from that circuit. The advantages of horizontal break type isolator. So, it has simple and robust design, making it reliable for easy to maintain. It offers good mechanical stability. That is why it is suitable for high voltage and high current applications. It provides clear and visible disconnection, ensuring safety during the maintenance procedure. Well suited for outdoor substations, especially in the areas with high pollution or environmental stress. Manual or motorized operation is simple and reliable. Because of its simple mechanism and exposed construction, maintenance is relatively easier. So these are several advantages of horizontal brake type isolator. State the limitations of horizontal brake type isolator. So there are several advantages as well as disadvantages of horizontal brake type isolator. It requires significant space in the horizontal direction for the installation and its operation, which can be a problem in compact size substations. Due to the horizontal movement and exposed parts, it can be more susceptible to wind forces, which may affect its operation and stability. Accumulation of dust, ice, or pollution on the horizontal contacts can reduce its performance or require more frequent maintenance. Typically it has a slower operating speed compared to other type of isolator like pantograph isolator or vertical brake isolator. Precise mechanical alignment is needed to ensure the proper contact engagement and disengagement. At very high voltages, nearly about 220 kV or more, other types like pantograph or vertical brake isolators may be preferred due to the better insulation and clearance characteristics because they operate in vertical direction like this. So ensures the proper isolation and reduces the arcing. So these are several limitations of horizontal brake type isolator. Explain construction of vertical brake pantograph type isolator. So insulated columns. Two insulated columns are used. One is fixed and another is the moving one. It is made up of porcelain or composite polymer. They provide necessary insulation between the live parts and the grounded structure. The fixed insulator holds one end of the conducting arm. The moving insulator is connected to a mechanism that allows the vertical motion. So in this figure you can see this. These are two insulator posts. One is fixed, another is the moving one. This is the moving one. This is the operating mechanism and this is the pantograph structure. Now, conducting arms or the articulated arms usually made up of aluminum or copper. The pantograph configuration includes pivot joints to maintain the mechanical stability and allow vertical movement. When closed, the conducting arms connect the circuits like this. When open, they move downward vertically like this, breaking the electrical path and providing visible isolation. So this is the upper part. When it is opened up, so this arm moves in downward position, this arm moves in downward position. Here this is the joint, again another joint, a joint and a joint. So these are pivoted joints which are included of the main part of the system of the mechanical assembly. So when closed, they form the connectivity circuit like this. When open, they move downward vertically like this. So it disconnects the circuit. It is operated either manually or via motor or mechanical drive system. and connected to the moving insulator and controls the vertical lifting, that is opened up, that is the closing and the opening, that is lowering of the pantograph arms, that ensures quick and reliable operation even under adverse environmental or weather conditions. Silver-plated copper contacts are typically used to ensure low contact resistance and durability. The moving contact on the pantograph arm meets with the fixed contact on the stationary side like this. Proper contact pressure is maintained to avoid the arcing. The entire assembly is mounted on a galvanized frame or steel frame structure that is designed to withstand the environmental loads like wind and seismic force. So this is the structure mounted on the solid support structure or base structure. This is the lower terminal, this is the upper terminal, and which is connected with the bus bar on the upper end. So this is how the vertical brake type pantograph type isolator is made up of. Explain working of vertical brake pantograph type isolator. So in this there is one post insulator per pole. Pantograph mechanism is mounted on that post. There is one terminal on the post. There is another insulator post beside the insulator post which is rotatable. So the main post is there where on which the pantograph structure is mounted and another is the rotated type of pole structure is available. This post is operated by the operating mechanism. Thus, the contact can go up or down with the help of pantograph mechanism. You can see in the figure this. This is the rotary insulator which can be rotatable with the help of this operating mechanism, and this is the structure or the solid insulator over which the pantograph structure is mounted. The arms of the pantograph come into vertical position in the closed condition like this. Due to this, upper two arms of the pantograph are joined to the overhead structure. So these two arms are connected to the overhead structure. You can visualize in this figure. These two arms are connected. These two arms are connected with the upper hand of the bus bar, that is the conductor. Due to this, the upper two arms of the pantograph are joined to the overhead bus bars. As a result, the current can flow from the bus bar to the lower terminal through the link of the pantograph like this. From this upper end to this link to this lower terminal, current is flowing from these two parts, from the bus bar to the lower terminal. In the closed position, the pantograph arms form a continuous conductive path between the two terminals, that is from the upper terminal to lower terminal. So current can flow easily from the bus bar to the lower arm. To open the isolator, the rotary insulator is rotated through the operating mechanism. Through this link mechanism, the blade of the pantograph comes down like this and the connection becomes open. So here it is connected with the bus bar and comes down like this and operated. So at that time the contact with the main bus bar is open or broken. This movement ensures a visible brake, which is important for the safety and maintenance. So this is how the vertical brake pantograph type isolator works. The advantages of vertical brake pantograph type isolator. So there are several advantages of this type of isolator. Some of are listed over here. It requires less horizontal space, making it ideal for compact or congested substations. It provides a clearly visible brake when in the open position, ensuring safety during the maintenance of a breaker. It is well suited for high voltage applications, typically about 132 or above kilovolt, due to reliable clearance and insulation. The pantograph mechanism allows for smooth vertical movement and ensure positive contact pressure. It can easily be used in double bus bar system, enabling flexible switching between the bus bars. It is not necessary that the three poles should be in one line. Thus, there is flexibility in mounting or installation of this type of isolators. Motorized operation for remote operation, improving its safety and control in modern substations. Vertical separations minimizes contamination on the contact surface, leading to improved reliability in dusty or polluted environments. So these are several advantages due to which vertical brake pantograph type isolator are mostly suitable for ultra high voltage substations. State the limitations of vertical brake pantograph type isolator. So there are several advantages as well as some disadvantages of this type of isolator. So the pantograph mechanism is mechanically more complex, leading to higher initial cost and maintenance requirements. Due to the more moving parts and joints, regular lubrications and inspections are necessary to ensure the smooth operation. It requires more vertical space when operating, which may be a constraint in indoor installation or areas with high restrictions. Usually not economical or practical for voltages below 66 kV due to its construction and cost. The multiple joints and links may suffer from misalignment or wear over the time, affecting its performance. The isolator structure is typically heavier, needing a stronger foundation and support structure. More expensive than horizontal brake or single brake isolators, especially when motorized. So these are several disadvantages of vertical brake pantograph type isolators. Types of interlocks available to avoid isolator malfunction. So there are three types of interlocks are available to avoid isolator functioning, that is malfunctioning. Interlock to operate the three poles simultaneously. So this interlock ensures that all the three phases are opened up or closed at the same interval. That is R, Y and B phase isolators are connected at the same interval. Interlock with circuit breaker so that the isolator cannot be opened without opening the circuit breaker, and the circuit breaker cannot be closed unless the isolator is closed first. This is termed as electrical interlocks, and isolator cannot be opened unless the circuit breaker is already open, ensuring no load is connected. Also, mechanical trapped interlocks or PLC SCADA based smart interlocks are also used for this type of interlocking. Third type of interlock is available with earth switch. So when earth switch is used with isolator, the earth switch cannot be closed until the isolator is opened. This is termed as sequential interlock. A sequence is enforced where isolators must be operated only after earth switches are open. So these are three types of interlocks available with isolator to avoid its malfunctioning in the system. List out specifications of an isolator available on its nameplate. So there are several specifications available on a nameplate of an isolator. Some of are like manufacturer's details, standards compiled, normal current rating, rated short time withstanding of the current, that is in kiloampere for 1 or 3 seconds, rated voltage, rated insulation level, rated frequency, rated peak withstand current, that is in kiloampere peak, type of isolator, type of current, its ambient temperature, its mounting type, whether for indoor or outdoor. It should be noted that the braking capacity and making capacity are not included because they are the specifications of circuit breakers, and isolator is and no load switch. So at no load, no making and braking capacities are required, so they are not mentioned in the specification list of an isolator. Explain the need of earth switch. So when the maintenance of the overhead line has to be done or carried out, it is disconnected from the substation, but this is not sufficient from the viewpoint of safety. This is because if other line is passing nearby, EMF is induced in the line, or there is some residual voltage or induced voltages may still be present due to capacitive coupling or backfeeding. This may give electrical shock to the operator. So to prevent this, it is necessary to ground the line after disconnecting it. For this, earthing switch is used. Earth switches often come with a visible indicators and interlocks that confirm a section of the system is safely isolated and grounded before any work is carried out. So for this, for the betterment, first of all, circuit breakers are opened up, then after isolators are opened, and at the same time earth switch is closed. So all the residual charge on the line are grounded. Electrical safety regulations like IEC or IEEE standards often mandate the use of earthing switches in specific parts of the system to ensure a fully de-energized and safe working environment for the operating personnel. So this is the need of earth switch. Explain constructional detail of earthing switch. So in this I have tabulated some components which are there in earth switch. So first is fixed contacts. So stationary conductors are connected to the ground bar or earthing system. In this, there is one connecting bar. When the earthing switch is closed, the end of the isolator is earthed through this bar. Means isolator is closed and it is earthed. Moving blade or a contact. Conductive arm that moves to make or break the contact with fixed contacts like this. The operating mechanism. The operating mechanism is either manual, motorized or spring charged mechanism to operate the switch. Insulators. Normally the earthing switch is mounted on the frame like isolator. Support structures that provide insulation between the live parts and the ground. Earthing terminal. The earthing terminal connects to the grounding system of the substation or switch gear. Interlocking mechanism. Interlocking of earth switch is provided with isolator. The earth switch cannot be closed until the isolator is opened, and isolator cannot be closed until the earthing switch is open. Arc quenching system. It is optional. Used in high-speed grounding switches to extinguish the arc during the fault events. So these are the constructional details of earthing switch. These are the components available in earth switch. And earth switch is mandatory as per the IEC or IEEE standard. Characteristics of HRC fuse. HRC fuse means high rupturing capacity fuse. So these are, one is cutoff characteristics, time current characteristics, I2T heating means for heating characteristics, prospective current pre-arcing value time characteristics, and last is discrimination characteristics. Define minimum fusing current and fusing factor related to fuse. Minimum fusing current means it is the value of that current due to which the fuse element melts. So the minimum value of the current which melts the fuse element is known as minimum fusing current. Fusing factor. Fusing factor is the ratio of this minimum fusing current to the current rating of the fuse. What are the factors on which the fusing factor depends? The fusing factor depends upon the diameter of the fuse wire or element, length of the element or the wire, material used for the fusing element or wire, cross-sectional area types means it is round or rectangular, size and location of the terminals, and types of the enclosure used. These are some factors on which the fusing factor depends. List out various types of isolators. Isolators can be operated manually. In addition to this, electric motor mechanism or pneumatic mechanism is also used for the operation of isolators. The following three types are the types of isolators. First is vertical break type, second is horizontal break type, and third is vertical pantograph type isolators. So these are mainly three types of isolators which are used in the power system for the operations. Compare switch and circuit breaker. This question is asked many times in the examination, so student must understand or listen it carefully. So switch is used to break the small value of the current, whereas circuit breaker is used to break the large amount of current. Switch is not used to break the fault current. That means the switch is used in the healthy condition only. Whereas in case of the circuit breaker, it is used to break the fault current. Also, that means it is useful in the fault condition as well as in the healthy condition. The switch is operated manually. In case of circuit breaker, the breaker is operated automatically in addition to manually. Trip coil is energized through the protective relay and trips the circuit breaker. For switch, the voltage level is low, whereas for circuit breaker, it is manufactured for medium and high voltage levels. For switch, the construction is very simple, whereas for the circuit breaker, there are a lot of components are included with each other, and with the help of the automation, the automatic operation can be done, so the construction is slightly complicated. In case of switch, there is reduced maintenance, and in case of the circuit breaker, as the components are more and it is operated on very high voltage level and it has to deal with very high current, the regular maintenance is necessary. The switch occupies reduced space, whereas for the circuit breaker, it requires large space or more space compared to the switch. Switch is normally of the indoor type, whereas the circuit breaker can be indoor type or outdoor type depending on the type and rating of the breaker and the application where it is to be installed. Switch is not costly, whereas the circuit breaker is very costly. So these are some points of differentiation between the switch and circuit breaker. The similarity between switch and isolator. So this question is generally not asked in the examination, but the examiners in Viva generally ask this question, that what is the similarity between a switch and an isolator. So there are several points of similarity between these two devices. First is, switch and isolator both have the circuit interrupting devices. Construction of both the devices is simple. Both requires less maintenance. Both have a full load current rating, as both carry full load current. Both are manually operated. Both are integral components in electrical protection and control systems. Neither device changes voltage or current levels. They simply open or close the circuit. So these are several points of similarity between a switch and an isolator. Compare switch and isolator. This question asked many times in the examination Viva was and also in interview. So you must listen it carefully and try your level best to answer in the examination and in front of the interview panel. So the switch and the isolator. Switch is used to interrupt the load current, whereas isolator is operated on no load condition. Switch is used for the reduced voltage level, whereas isolator is designed for high voltage, and it has to be used with the circuit breaker, and circuit breakers are generally used for medium as well as high voltage levels. Breaking time is important in switch, as the load current has to be broken by the switch only, whereas isolator has to be operated only at no load condition, so the time of operation is not important for isolator. Sparking occurs across the contacts of the switches when the contacts are separated, whereas for the isolator, no question of sparking, as isolator operates on no load, because isolator only operates after the operation of the circuit breaker. Means once the circuit breaker opens up, after that the isolator opens. Contacts get worn out after some time due to the sparking in case of switches, whereas for the isolator, there is reduced maintenance as the load current has not to be broken by it. The switch is normally of indoor type, whereas the isolator may be of indoor type or the outdoor type. The switch is normally of manually operated type, whereas the isolator may be manually operated or motor or pneumatically operated. So these are several points of comparison for switch and isolator. The similarity between circuit breaker and isolator. Generally, the examiners asked a question like, what is the difference between a circuit breaker and an isolator? But this question is also equally important because we must understand the similarities between these two devices. So, rated current flows through both the devices during the healthy situation. Both the devices like circuit breaker and isolator are used in switchyard, receiving stations and substations. They both operate at the same voltage level. Both these circuit breakers and isolators are used to open or close electrical circuits. Both can be manually operated, motor or pneumatically operated. Circuit breakers and isolators provide a visual indication of whether the circuit is open or closed. Both these devices can disconnect part of a power system, helping isolate equipment for maintenance or for fault handling. So these are several points of similarity between the circuit breaker and isolator. State the similarity between fuse and circuit breaker. So generally the question asked was like compare fuse and circuit breaker. But many times in a Viva and interview exams, they are asking a question like, what are the similarities between the fuse and the circuit breaker? So today we are going to discuss the same. So both the fuse and circuit breaker are protective devices used to protect electrical circuits from overcurrent, including short circuits and excessive load, means overloading. Both work by interrupting the flow of current when it exceeds a safe level, thereby preventing damage to the circuit or connected equipment. Both help to reduce the risk of fire and protect electrical appliances by disconnecting the faulty circuits from the healthy one. Both are essential components in residential, commercial and industrial electrical systems for ensuring electrical safety. The main point of similarity between these two devices is the type of connection. Both are connected in series with the circuit. They protect so that any excessive current must pass through it. So these are some points of similarity between fuse and circuit breaker.